Now let's move to the third question. So the third question is, how many photons are emitted per second by a 1 milliwatt helium neon laser, and what is the average time interval between the emission of two successive photons? So here the power of helium neon laser is given, and that is equal to 1 milliwatt, and the question has been asked, we have been asked to calculate the number of photons emitted per second. So we know that since we know that energy by time is power, so energy is equal to power times T, and we have been asked to calculate the number of photons emitted per second. So here we will take time is equal to 1 second. So our energy will be E is equal to 1 milliwatt times 1 second. So this energy will be 1 millijoule. So now let us convert this joule factor into electron volt. And so since 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule, so 1 joule will be 1 by 1.6 into 10 to the power 19 electron volt. And now assume n is equal number of photons emitted per second, emitted per second. So our energy will be equal to n times h nu, and this will be equal to 10 to the power minus 3. This 10 to the power minus 3 factor comes from this millifactor divided by 1.6 into 10 to the power 19 electron volt. And since we can also write this energy as n times hc by lambda, and this equals to 10 to the power 16 divided by 1.6 electron volt. And here lambda of the helium neon laser, we have to take lambda for helium neon laser, for helium neon laser equals to 632 nanometer. It is roughly equals to 632 nanometer, and precisely it's equal to 632.8 nanometer. So now you can also write n is equal to lambda times 10 to the power 16 divided by hc times 1.6. So this will be equal to 632 nanometer into 10 to the power 16 divided by 1240 electron volt, and obviously an electron volt here, nanometer into 1.6. So nanometer gets cancelled out, electron volt gets cancelled out, and we are left with 632 divided by 1240 into 1.6 into 10 to the power 16, and this roughly comes out to be 3.2 into 10 to the power 15. So 3.2 into 10 to the power 15, this number of photons will be emitted per second from a helium neon laser whose power is given as 1 milliwatt. Now this question has a second part also, and the second part is what is the average time interval between the emission of successive photons. So total number of photon is 3.2 into 10 to the power 15, and total time is 1 second. So time interval, or its average time interval. So the average time interval is total time by total photon, 3.2 into 10 to the power 15, and this comes out to be, I think, nearly 3.1 into 10 to the power minus 16 second. So this is the answer.